everyone. I'm here to give you a short presentation about the project where we've been involved. The project name was AppSentinel, which means Intelligent Cloud-Based Anti-Malware Technology for Android App Stores. Well, my name is Carlos Serrão, and I'm an associate professor at ISTAR, and I'm also a researcher from ISTAR-IUL, integrated in the Software Systems Engineering Group. Okay, so the problem this project tried to address was the problem related with mobile applications malware. Currently, there are too many unsafe, malware applications and vulnerable applications on mobile app stores. So basically, we are talking about mobile applications for Android and iOS, although this project only addressed the case of Android applications. And this is a problem because most of these malware applications or vulnerable applications are available in the app stores for the end user installation on their own devices. So our hypothesis while developing this project was to consider if we could develop some methods that in an automated and intelligent way could be able to reduce or even eliminate the number of unsafe applications from app stores. So, AppSentinel is a cloud-based technology for Android app stores that aims to build processes for preventing security breaches on mobile devices and also allows the implementation of some quicker reaction time to new mobile threats for app stores managers. So these are the two main objectives of this project. So this was a project that was developed together by Aptoid and ISTAR. Aptoid is an app store for Android mobile applications that allows the distribution and installation of Android mobile applications on Android devices. It acts like an alternative app store to the default Google Play Store that usually comes by default on every Android device. Both of the teams from ISTAR and Aptoid worked together for around 2 years in the development of technology to address the problem of malicious and unsafe applications on app stores. So, what is the main context, the main rationale behind this project? First of all, mobile computing is becoming increasingly complex and popular. For instance, if we consider the global market for mobile applications, we are talking about two major platforms that dominate this market. There are the Android market, and then there is the iOS market. So one is more or less ruled by Google, and the other one is more or less ruled by Apple, in which clearly Android dominates the market with a market share of around 80%. Users are also progressively adopting mobile platforms as means to support tasks such as messaging, e-commerce applications, home banking, and so on. There are around 205 billion apps that were downloaded and installed just in 2018. So there is a lot of applications being used and being installed by every user on their own devices. The problem with these applications is that the most of the data that these applications has to handle is more or less sensitive for the user. So we are talking about our personal messages, our personal information, our personal pictures. So everything we own on our own mobile devices is quite sensitive for someone else. And this also makes them really attractive for someone trying to attack you and your device. So they are really a good platform for malware authors to develop their own specific malware, to make them available to the end users in order to trick users to install them as normal applications, and afterwards attacking the user and attacking the device of the user and try to get some sensitive information from the device. Well, looking at the traditional app submission process that occurs on app stores like Aptoid in this case, when the developer or a company submits an application, this application is passed through an antivirus. So actually there are a set of antivirus technologies which are used against the application that is submitted by the developer. And if one of those applications flags one of those antivirus flags the application as a potential virus, the application is discarded. Even if the application passes this antivirus scanning process, it goes through another evaluation process, which is called fake detector, which actually looks at the application and tries to identify if this application is trying to mimic another application on the store. For instance, it's an application that is trying to fake another application which already exists. So it's a fake application. If the application is flagged as fake, it's also discarded from the store. But if the application goes through this process of antivirus detection and also fake detection, the application is made available on the App Store, and actually every user using that App Store can download and install that application on their devices. There is also another process that occurs afterwards, that when the user is using the application itself, it can provide feedback to the store saying information or giving information about the application itself. It looks like a fake application, or the application is not performing as they would expect, and so on. And based on this feedback, the quality assurance team of the App Store itself can also discard one existing application on the store based on the feedback provided by the user. So this is usually the traditional app submission process that occurs on normal app stores, and in this case this is what happens in Aptoids. But this has some serious problems. For instance, the first problem that this process has is in terms of performance and cost, because every day 15,000 new Android applications are submitted. So this means that all of this process needs to be repeated according to the new submissions which are made to the store itself. So this takes time, this consumes a lot of resources from the App Store itself. The other problem that occurs is that the detection of new threats is usually a long process, because the only way the store has to detect new threats is based on the feedback provided by the end user. So it has to somehow have the feedback of thousands of users about how that application is misconducting on their own devices, and afterwards it can be identified as a new threat and should be admitted from the App Store. And there is another issue which is even more important, that is the fact that usually new threats, so every time a new malware is launched or is produced and the antivirus technology doesn't detect it, or the fake detection process also doesn't detect it, this kind of malware is always successful, is always present on the App Store, and is always available for the end users to download it and to install it on their own devices. So the major goal of this project was to try to somehow improve this process. So the major objectives were to somehow using some kind of methodology for automatic learning of static and dynamic malware patterns on mobile applications in order to detect them in a more intelligent way before making it available on the App Store. Also using app profiling algorithms based on a rule set for automated detection and automated learning of new threats. Also develop a system which was capable of analyzing the user's feedback regarding the potential malware situations and somehow incorporating it onto the learning system so that we can improve the learning process of the system in order to recognize malware in a much faster and in a much more efficient way. Also, another important goal of this project was to allow the system to automatically identify mobile application vulnerabilities. So we are not just talking about malware, but we are talking about also problems, security problems existing on the mobile applications by design, and somehow provide the developers of those applications feedback about these security vulnerabilities that were detected on their own applications in order for them to improve their applications and correct the vulnerabilities that were discovered by our system. This slide presents the overall architecture of the AppSentinel project. As you can see, there are a set of building blocks on this architecture that allows us to first receive the application from the developer, pass that application to the different controls and the different security verifications that we have implemented on the system, and at the end provide some feedback for the App Store Quality Assurance Manager and also for the developer in order to first detect if the application submitted is or not malware, or it can somehow suspect or not if the application itself is malware, and secondly trying to provide information also for the App Store Manager to know if the application that was submitted is or not a vulnerable application in terms of security, and if it contains some vulnerabilities, the developer itself will receive feedback from the system with information helping the developer itself to correct the vulnerabilities that were detected and allowing the developer to understand how to improve their own development processes. Okay, summing up this whole architecture of the project, we just want to highlight three major components of the system that somehow tries to address the problem of this project. The first one was about intelligent app analysis. So we are trying to leverage the analysis of static and dynamic malware, trying to analyze thousands of applications which are submitted to the App Store itself, and learning with some malicious patterns that are that enable us to identify new types of malware. The other important component of this architecture and this project were the support for the security and quality assurance process of the App Store itself. So we provided important information for quality assurance managers to decide if they accept or not the submitted app on the store to be available for the end users. So we allow them to define specific rules in order for them to accept or not this new application. And finally, the other component which was also extremely important in this system were the component that allows us to analyze potential security vulnerabilities on the applications which are submitted, which may not actually be malware, but they may contain some security vulnerabilities that may affect the end users when they are installed on their own devices. And so the purpose of this model was also to provide information about the discovered security vulnerabilities and to provide the necessary feedback for developers for them to try to correct this situation. On what concerns malware detection, in the project we were using two different types of approaches. The first one was static malware detection, in which actually we took the submitted application, we didn't execute the application itself, we just parsed the source code of the application itself, and then we look at the structure of the code and we try to understand how the application was implemented. We also looked inside to some specific files inside the application, namely the manifest file of the application itself, in order to understand which were the kind of permissions the application was requesting to the device and to the end user, in order to check if the application is not asking too much permissions than it actually needs to be executed on the device. When usually an application asks for too many permissions than the ones it needs, it usually is a sign that that application may have some kind of malware behavior. The other type of malware detection used was dynamic malware detection. In this case, the application is executed on the sandboxed environment in order to monitor its own behavior. For instance, we are looking if the application, which kind of access to the network the application has, which type of access to the file system the application has, which are the requests that the application may produce in order to access to other apps installed on the system, and so on. So we were looking at the dynamic behavior of the application itself when it executes on the system of the end user. And so the input and outputs of the application itself are also analyzed in order to identify potential threats. Well, in the vulnerabilities detection part of the project, We address the problem of detecting vulnerabilities on mobile applications by first reverse engineering the Android mobile application. Basically, we take the APK, which is the file which contains the application. We analyze the source code, not exactly the Java source code, but we analyze an intermediary code which is called Smally. And then we execute different vulnerability detection tools, harmonize the results given by those tools, calculate the security risks which are presented by the different vulnerabilities that are detected by the tools itself. And finally, we provide feedback to the users in order for the users to understand which are the vulnerabilities and how those vulnerabilities can be fixed. This is the architecture that was developed for the system that analyzes the Android apps submitted by the developers and tries to detect security vulnerabilities in them. And in the end, it provides feedback to these developers. This architecture uses a service-based approach where a simple API is provided for both developers and the App Store managers to submit mobile applications for analysis. When an app is submitted, a set of different vulnerability scanners are executed on top of the application, and the different results are collected. After this, the results are combined, and using a knowledge base, the feedback is built containing the different detected vulnerabilities and some information that might help the developer to understand the vulnerability as well as the way to fix it. As a way to test the system, we analyzed three different Android app stores in this case, and we look at the most downloaded applications from those app stores and try to detect how secure they are. So we consider the Aptoide App Store, the Google Play Store, and also APK Pure, which is another app store. And the conclusion we reach is that all of those stores contains lots of applications with security vulnerabilities. And if we compare this against the OWASP Mobile Top 10, we can look at the different prevalence of unsecure applications on those app stores as well. We have another graph that shows also the number of vulnerabilities according to the severity type of the vulnerability itself. So we can look and see that both Aptoide, Google Play Store, and also APK Pure, they all contain applications which are unsecure and which may actually make the end user a target for someone trying to exploit this unsecure application that the user might have installed on their own device. Well, the major results from this AppSentinel project were that the developed system is actually a working system at the Aptoide App Store, and it was integrated on the app's quality assurance processes of that mobile application store. We also have produced some publications, some articles that were published and presented in some international academic conferences, and some other articles were submitted to major international academic journals. Some of those are still under evaluation. We also have had 5 master students working in this project that actually have done their work on this project and have successfully completed their own thesis. And also part of the system source code is available. The part that is specific to the app's vulnerability detection system is available on GitHub, so anyone can look at the source code, download the source code, and even improve the source code. So, and this is the presentation of the AppSentinel project, a project that tries to improve both the malware and to reduce the malware on mobile app stores, and at the same time try to make app stores a much safer place for anyone downloading applications to their own mobile phones.